Okay, welcome back to our second video, as promised, talking about the concept of present value. And specifically, we're going to talk about the function in Excel XNPV. So quick reminder of why we use present value and what we did in the previous video, which was net present value. So in the previous video, we talked about the concept of present value and net present value. And with net present value, the reason we use a net present value function instead of the present value function is when you have an equal distance of time between cash flows. For example, just say 30 days between each payment, but you have uneven cash flows between each payment. And if you remember the present value function, the regular present value function, just PV, assumes that there's equal distance between cash flows and the cash flows are the same. So equal distance and equal cash flow between each installment. When you have an uneven cash flow with equal distance between each cash flow, you'd use the net present value function, which we talked about in our previous video. And where I left you off is, hey, so what do you do if you're trying to calculate present value, but you've got an uneven distance between cash flows like you see here, and you've got uneven cash flows with each payment as well. So when you have an uneven distance and an uneven amount per cash flow, then all of a sudden net present value doesn't work because net present value assumes equal distance between cash flows. Okay. So in that situation, you are not lost. You have a different function that you would want to use called XNPV. But just like with net present value, in which I showed you how to calculate net present value manually, I want to show you how to calculate net present value, present value manually using the XNPV concept. And then I'll also show you how to use the XNPV function, which I don't know why that's spelled wrong. It's XNPV instead of XPVN, which is the way it was typed. Okay, so XNPV. So net present value with distance values, different distances between each value. So to manually calculate XNPV, you'll have to first calculate the distance between cash flows, and then you'll have to use this formula down here to calculate the discount rate per cash flow. And then you'll use some product to calculate the XNPV based on the expenses or your cash flows and your discount rates. So step one is you got to calculate the distance between each cash flow. So there's an easy way to do that. So the easiest way to do it is to take the starting cash flow minus whatever current cash flow, and we're not talking about cash flow, but it's actually the time frame. So 1/20/2013 is what we're going to take. Okay. And we're going to subtract from it that same one because we're on the very first payment. And then we're going to divide it by 365. Now we need to use order of operations here. And when we do this by default, we're going to get 0, which would make sense because that's our first starting point. So now the second distance is going to be slightly different, right? So we're going to take our date of 3/5/2013. We're going to subtract from that date our 1/20/2013. We're going to divide that by 365. And what that's telling us is it's going to tell us the fraction of the year, basically. Instead of telling us the actual amount of days, which is what you would get if we didn't divide by 365. So boop, we're going to get that. So now at this point, if I absolute reference cell A3, there we go. We are then going to boop, knock that down, and that's telling us the distance, right? So this is the fractional distance between each point. So once we do that, we need to calculate our discount rate per cash flow. So we're going to discount each cash flow based on this discount rate of 5%. So to do that, we're going to use this little formula here. Okay, so you see it? It's 1 divided by 1 plus the rate to the power of the distance. So we're going to jump right here. We're going to take our 1 divided by 1 plus whatever our interest or our discount rate would be, raised to the power of our distance, and the distance we already calculated is right there. Now we need to absolute reference our discount rate to make sure that locks in. And at this point, we're able to go ahead and fill this thing down. So there we go. So we've got that. We're good. So this is our discount rate. These are our expenses. So now if I were to do a sum product of my expenses and my discount rate, as you know, it would tell us individually what each discounted cash flow would be, and then it would add them up. That's what sum product does. Okay. Got a different video on that if you don't know how sum product works. and it gives me negative 2,134.16. Okay, that's the hard way to do this. Okay, so we have a negative total present value cash flow here. So the other way to do this is using this nifty function in Excel called XNPV. So XNPV is really simple. It's got 3 required arguments. The first argument is going to be rate. You know, in this case, the rate is the discount rate, which has been given at 5%. Okay. So the next thing you got to do is just feed it your values. You feed it your total value, so all of them. So it'll be all the different cash flows. We're going to plug those in, which would have been a little different from net present value. Okay. And then we're going to feed it the dates. Like so. And you know what we're going to get? Oh, look at that. The exact same thing. So XNPV is really, really easy. I've shown you the math behind it. In the real world, will you have to do the math behind it? Probably not. Just using that XNPV function is really the way to go. But I will say, if you're listening to this video because you're in a class with me, it would be really good to make sure you know how to do both of these things. All right. This one, excuse me, just throw that out. So quick refresher, one more time. Why do we use the XNPV function? So the XNPV function would be used when you're dealing with cash flow analysis and you've got different distance between cash flows and you've got different cash flow amounts. So uneven cash flows with uneven distances between each cash flow. That's why you'd use XNPV, because NPV, the net present value function, assumes equal distance between cash flows. And the present value function in Excel assumes equal distance between cash flows and equal cash flows. So short and sweet and to the point. XNPV is our friend. We really like that. Next time I see you, I'll talk to you guys about internal rate of return, multiple internal rate of return, and the rate function. So I will see you back shortly.